Please welcome Teratonix from Carnegie Mellon University.
Thank you. Beep, 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 beep. Have you ever heard this sound from your smoke detector? Beep, 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 beep. Isn't it annoying? Hi, my name is Ivan, and I'm happy to tell you about Teratonix. At Teratonix, we developed a revolutionary device to convert ambient radio waste to electricity and provide a maintenance-free replacement for batteries. There are going to be 26 to 50 billions of connected devices by 2020, and there is no way all of them will be powered by wires. It would cost too much to throw additional power line to every single sensor, beacon, or smoke detector. Batteries work well to some point. They're cheap, well-known, and seem to be so easy to replace, which is true if you have one smoke detector or 5. But if you have 1,000 of them, changing batteries becomes a serious problem. By 2020, 1 million maintenance workers will be needed globally to change 26 billion batteries. Each of them 26,000 batteries per year, or 100 per workday. Worth mentioning, in the US, it is considered to be an electrician-type job. And on top of that, in many large entities, CMU included, it is a union shop job. That's why it costs so much. Another huge problem, battery waste. 3 billion batteries, or 180,000 tons of hazardous waste is dispersed per year in the US only. The increase of this number could be really detrimental to the environment. So how do we save the world from turning into a battery landfill? The solution is to generate electricity at the spot. Devices that convert solar, thermal energy, or mechanical motion to electricity called energy harvesters. Unfortunately, sources of ambient energy are not always available. Wind turbines need wind. Solar panels need sun. Thermoelectric generators need high temperature gradient. Radio waves, or radio frequency radiation, is probably the most convenient source of power, ubiquitously available in a typical urban environment. The energy comes from radio and TV towers, Wi-Fi and cell phone transmitters. We, users, consume only a tiny portion of this energy. 99% is wasted. At Teratonix, we can collect this energy and send it back to work. What can we do with this power? Oh, yeah, I'm staying here. So by generating electricity at the spot, we cut lifetime maintenance costs for wireless devices by a factor of 10 when compared to batteries. We eliminate hazardous battery waste. We provide stable performance independent of weather conditions. We enable truly ubiquitous IoT proliferation and placement of sensors in all required locations, which is a critical element of the future industrial development, where multiple sensors will be placed in all possible locations and provide timely and precise information from all production phases. This is probably the most technical slide in my presentation, and it explains why we have the first technology on the market to produce a meaningful amount of energy. Due to the limitations of the state-of-the-art methods, current technologies can target only a very narrow frequency range and collect energy from only one source of energy, Wi-Fi, for example. Another key difference is that at Teratonix, we can collect very weak radio waves, starting from low microwatts all the way up. Alternative solution can target only the most intensive portion of the signal. So what can we do with the energy that we can collect? Let's consider smoke detectors again. Manufacturers of low-power devices claim that their devices can run on a single battery change for 3 to 5 years. In reality, the discharge rate of every device is determined by many factors: location, temperature regime, operation regime. For example, smoke detector that is installed by the outside entrance overall works in a cold environment. The battery discharges at a faster rate. It needs to be changed more frequently. And in large entities, it is close to impossible to keep track of battery changes here and there. So what happens is that maintenance workers change all of them at once, usually once per year. Powered by Teratonix, sensors will run for a lifetime. Teratonix Energy Harvester is a passive device. There is no moving parts or anything like that. There is nothing to break. It can last even longer than the powered device. And this is where all of these devices will be used. This is how the future factory will look like. It will be full of smart wireless devices, sensors, smart meters, active RFIDs, beacons, and of course, smoke detectors. The Teratonix Energy Harvester can power up most of these devices. According to BCC research, over 88 million of RF energy harvesters will be installed by 2020. The absence of the alternative, equal efficient technologies allow us to seize 30% of this market. Our direct customers are low-power device manufacturers, and there is such a need on the market for maintenance-free solutions that their customers and IoT users are willing to pay double price for maintenance-free solutions, according to our research. So we sell battery replacement, IoT manufacturers sell self-power devices, end users save on maintenance expenses. And the value that we create with our technology is so high that there is enough margin for all of the stages of this food chain. At the later stage of the development, we will license our technology out to large electronic companies manufacturers. And the economies of scale they will be able to achieve will drive the price for the device down and allow truly ubiquitous technology proliferation. The effectiveness of our technology is attributed to proprietary ultra-high-speed die developed in CMU. That's on the first slide. Small, thin, and microscopic increase on the top. And that's a small thing on our testing bed that we use now. I guess it is too far to see for you, but someone have seen it, and I can show you in more details. So this is our testing bed, and this is what we are working now. Instead of our direct input we use now, we will have the antenna that will collect the whatever energy is in the air, and LED as an output that will blink every time enough energy is collected. In 2 months or so, we will have this technology working, and it will be really cool to see how it works with no intentional energy applied. Almost a magic. After the prototype demonstration, we will be ready to raise our first round of capital to develop a scalable manufacturing technology for our diodes and energy harvesters. As a result of this stage, we will have a manufacturable device that will require only working capital to produce. And this is our team. Dr. E. Lo, the inventor of the diodes, has over 2 decades of experience in nanoscale semiconductors. Ivan Pistsov, 12 years of entrepreneurial experience, including 4 years running industrial automation company. And our advisor, Dr. Rick Carley, a world-known expert in design of analog circuits. And again, at Teratonix, we developed a revolutionary device to convert ambient radio waves to electricity and provide a maintenance-free replacement for batteries. Thank you.